Hello everyone, Professor Caleb with you guys back at it again. Ignore this, I messed up my first attempt, so I'm restarting. But anyway, so guys, what's our problem today? So you want to find out the natural abundance of copper. Okay guys, let's get started. So, the atomic weight of copper is 63.55 AMU. So the atomic weight, AW of Cu, is equal to 63.55 AMU. Yeah, because what we want to know is the natural abundance of the isotopes of copper. So let's start. We have two isotopes of copper, only two isotopes of copper. So this should be easy to solve. So we have an isotope of copper with a mass number of So we have an isotope of copper with of 63, which is equal to 62.93, or we have an isotope of copper with a mass number of 63. And we have an isotope of copper with a mass of 65, and its weight is 64.93. Yeah? I got a little confused there, I'm sorry, because on the document it's written like this. Pretty sure this is wrong. I'm pretty sure that would be the atomic number. The atomic number of copper is not 63. The atomic number of copper is always the same. So I assume what she meant was the mass number of copper. Anyway, guys, that's fine. But anyway, it's kind of obvious. I just got confused on my own problem. And I forgot to write 3 here. Sorry. Is it 3? Wait, is it? Yeah, sorry. Wait. Okay, anyway. And these are all in AMU. Sorry, everyone. Starting a bit there. But anyway, that would ask, what is the percentage of abundance of these two isotopes? Now, guys, if you recall correctly, what this is basically saying is the atomic weight of copper is 63.55, and atomic weight basically just means the average weight of all the isotopes. So the average of these two. However, there's a problem. You think if you're trying to find the average, you should just multiply. So let's say the average of. What's the average of 3 and 2, whatever? Yeah. So if you want to find the average of 3 and 2, you just divide by 2 and add them together, or whatever, right? Then that's your answer, correct? However, with this, these are not the equal amounts. For example, this isotope could have more in nature than this isotope, meaning we need to find a percent of nature that these isotopes occur. So, ready, guys? So let's kind of start writing our formula. So our formula for this problem will be x times, and x, it's going to be, you'll see, 62.93 plus 1 minus x times 64.93. We know this is equal to our atomic weight, which is 63.55. Now you may be a little confused, Gus, because since these two percent could be different, you think there would be x and y. But no, Gus, that would really wonder your word. So we know what is 100%, Gus. 100% is this, right, Gus? 100% is equal to 100 over 1. 100 over 100, right? You write that down, Gus? Yeah, he got it. And 100 over 100 is equal to what? 1. So, our two numbers, percentages, will equal up to 1. Or to 100%. So, we can find out the natural abundance of this number, and then we just have to subtract 1 minus that number to find out the abundance of this number. Does that make sense, Gus? Yeah, you got it down. Now, Gus, so the first step is to multiply this out, so 64.93, and this out. Well, I guess you would get the idea. Plus, the x plus 64.93 minus 64.3x equals 63.5. You got that down, Gus? Let me see how we did that. Now, we're going to solve for x. And how do we do that, Gus? Well, our first step is to combine our like terms. So 62.93x and negative 64.93x go together, and this will give us negative 2x plus 64.93 is equal to 63.55, right guys? Now we need to get x alone. To get x alone, we need to subtract by 64.93 on both sides, obviously. And this will leave us with negative 2x is equal to negative 1.38, right? And now we need to get x alone again. So to remove the negative 2, we just divide by negative 2 on both sides. And this means x is equal to negative 1.38 divided by negative 2. Right, guys? And if you were to input that to your calculator, it would give you x is equal to 0.69. Now guys, take a guess what this means. That's right, guys. 0.69 is equivalent to 69%. Or is equal to 69 over 100. Sorry, bad handwriting. Is 69%. So we found out the natural abundance of our first element, or isotope, sorry. So the natural abundance of copper, the isotope copper with mass number 63 is 69%. Now we need to figure out the mass. We need to figure out the natural abundance of isotope of copper with mass number 65, which is pretty easy. You just do 1 minus 0.69, and this will equal to 0.31 or 31%. So meaning our natural abundance of copper isotope with 63 mass number is equal to 69%. 69%. And with 65, copper is 65 mass number is 31%. And if you don't believe us, we can actually check our work. So let's go do that. So if we were to put it into our calculator, sorry, let me write it down first so you guys can see what I'm doing, what I exactly do. And this will equal to 63.55 hours. So let's check this to make sure I did it right. It'd be quite embarrassing if I messed it up. So 0.69 or whatever I wrote times 62. Sorry, I was calculator. 0.69 times 62.93 plus 0.31 times 64.93. This gives us 63.55. And would you look at it, Gus? That's exactly what our atomic weight is, meaning we did the math right. So to reiterate, this is our final answer. Hope this helped you out, Gus. Peace out.